My dear friends, welcome back to BSpice. In this session, we'll focus on future of DCS, meaning emerging trends and technologies in DCS. In fact, we have covered the DCS aspects, design, architecture, the logic, everything in detail in our BSpice channel. But this is more of, something on top of that, meaning the future of DCS. Okay. There are a lot of technologies. Okay, this will bring new capabilities to the DCS and increase the efficiency and safety of industrial processor. For example, the integration of artificial intelligence, AI, and machine learning, ML, right? So that will enable the predictive maintenance and real-time optimization. And also the integration of IoT that will allow for remote monitoring and advanced analytics actually, right? Additionally, we also have a cloud-based solutions, right, that will allow for scalability and reduce the cost associated with the on-premises system, meaning the system, DCS system inside them. And edge computing technology that will also reduce the latency and increase the reliability of data communication. So this all the future of DCS, friends. And there are also nowadays, we are having a 5G, right? Fifth generation technologies and IIoT. So all these actually, gives, will take the DCS to the next level. So not only in that, there are many more advancement. This AR, augmented reality, and HMI. All these will provide the operators with more intuitive and immersive interface for monitoring and controlling the processor. Okay. So since we talked about the AR, see, it's basically augmented reality. Of course, I'm going to talk about that in the subsequent slides. So let us go into the detail. Okay. So first and foremost, Industry 4. This is one of the emerging trends and technologies in DCS. Integration of Industry 4 technologies such as AI and ML in DCS will enable advanced capabilities like predictive maintenance, real-time optimization, and autonomous decision making. Then we have a IoT. By integrating, IoT technologies with DCS system, it will allow for a remote monitoring, real-time data collection, not the near real time. It's a real-time data collection without any latency and advanced analytics, improving the efficiency and safety of the industrial process. Okay. Then comes the cloud computing. Using cloud-based DCS solution, which I'm going to talk in the next video in detail, a separate exclusive video on cloud-based solution. Okay. So it allows remote access and control, as well as the ability to scale up or down as needed. Just like that. We want to scale up, you can increase. And if you want to downsize, you can downsize them. So basically reducing the costs associated with maintaining a on-premises DCS system. Just imagine you have a system inside and you have, additional hardware, all these, it's like, add on, what do you call, add on cost. See, if it is a cloud-based solution, you can only pay for what you need. That's it. As you need, you pay. That's it. Very simple. Of course, we are going to talk about that later. Okay, so these are the things and few more edge computing. See, edge computing, this will allow for the processing of data closer to the source inside them. So thereby reducing the latency and increasing the reliability of data communication. Important in industrial environment where real time control and decision making is critical, isn't it? So apart from that, we also have virtualization and decentralization. Virtualization technologies will make it possible to decentralize control function and run them on a small, low-cost devices, so thereby providing more flexibility and scalable DCS architecture. You don't have to, bring the complete system, big system. Just go with a small one, and yeah, then you can scale, increase your, the requirement as we progress. So ultimately, we'll end up in lowering the total cost of ownership. Remember, friends, always when we do some projects, we should focus on the TCO, that is the total cost of ownership. Then 5G and IIoT. 5G, the fifth generation networks are deployed, and IIoT becomes more prevalent. DCS will have to be designed to handle the increased data traffic and more connected devices, requiring new communication protocol technologies as well as more powerful edge computing and data analytics capabilities. So these are the future actually. So that is the point. Okay, then we go into the augmented reality. Basically, augmented reality is a technology actually that overlays digital information onto the real world, enhancing our perception of the reality rather than replacing it. So basically, the interactive experience can include, visual, auditory, or maybe other sensory modalities. How it works, AI works by using devices equipped with cameras, sensors, and displays such as smartphones, tablets, or smart glasses. These devices capture the physical world and integrate digital content like 3D models or videos. So that's about the augmented reality. But coming back to the subject here, AR and HMI technologies will provide operators a more intuitive and immersive interface for monitoring and controlling purposes, which will help improve the efficiency and safety of industrial process. This is one of the future trends. And of course, cybersecurity, with increasing connectivity of DCS to internet and other networks, cybersecurity will become an increasingly important aspect of DCS. I hope you agree also. And yeah, we are going to talk about that also in a separate session, a subsequent session on this cybersecurity in DCS. So requiring a proper security measures to protect the system and the process it controls. Then the decentralized control. Future DCS will move towards a decentralized control architecture that allows for independent and adaptive control of different subsystems or devices. So you may have a question like, what is the adaptive control? Yes, adaptive control is a type of control system that adjusts its parameters in real time to cope with the changes in the system or the environment. See, basically, this is useful in situation where the system dynamics are uncertain, right, or vary over a period of time. Some of the examples, like a self-tuning. Adaptive control system can automatically adjust the parameters to maintain optimal performance without human intervention. So that is the beauty of this. And of course, it is very robust actually. And when we talk about the application of this adaptive control, is used in various fields, in fact, friends, like, aerospace for flight control system and for automotive engine control and also the robotics for motion control. And of course, our own process industries for chemical process or, petrochemical refinery, all these. So these are some of the emerging trends and of course, few more. Yeah. Advanced analytics. So advancement in data analytics and processing power will enable more advanced analytical capabilities, such as real-time process modeling, predictive maintenance, and optimized control strategies, and integration with other systems. DCS system will continue to integrate with other systems such as ERP, Enterprise Resource Planning, or MES, Manufacturing Execution System, and SCADA, providing seamless integration of various plant systems and thereby improving the overall efficiency of the plant. And remote monitoring. Remote monitoring and control will become more important in the future as it enables companies to optimize the operations and reduce costs by monitoring and controlling the processor remotely, right? As I said, like cloud, having the DCS in cloud, right? Yeah, those kind of things actually. So yeah, these are the things I just want to share with you as far as the emerging trends and technologies in DCS. Okay. Thanks for watching, friends. And yeah, again, I seek all your support. So next, I'm going to talk about the cloud-based DCS. Cloud-based DCS. What is cloud-based DCS? How it is going to helpful? All these I'm going to talk. Thank you. Take care. Bye.